In lab, you guys were investigating acceleration. We saw what happened to the velocity of a cart as it rolled up and down an incline. And we're going to use those results to generalize a definition of acceleration and explain what acceleration means. So acceleration is a measure of how quickly an object's velocity changes. Now remember, velocity is how quickly position changes. So when velocity changes, the object is either speeding up or slowing down, and since velocity includes direction, it could also be changing direction. The units of acceleration are meters per second per second. You will sometimes see me write that as meters per second squared. Those are equivalent units. They mean the same thing. They mean how much the velocity changes every second. So an acceleration of 2 meters per second each second means the object's velocity increases by 2 meters per second every second. That is to say, if it was moving at 0 meters per second, a second later it'll be moving at 2 meters per second, and a second after that it'll be moving at 4 meters per second. It's getting faster by 2 meters per second every second. Notice that that's not the same thing of velocity. A velocity of 2 meters per second means every second the object moves 2 meters. This is going to be a nice constant generally increasing position on a position time graph. If it's getting faster though by 2 meters per second every second, it's got to start slow and get faster, which means it curves. We'll look at that in a later lab. Now, a velocity time graph is exactly what it sounds like. Over on the left, it shows velocity. Remember, that's how fast it's going. Anything up here is positive, and that means it's moving away. Anything down here is negative, and that means it's moving towards where it came from, or towards the reference point. And we saw a variety of velocity time graphs. We saw steeper ones, less steep ones, fairly shallow ones, okay? And those just indicate this is a quick acceleration. It's getting fast, fast. Here it's getting fast, but it's getting fast slower. All of these lines indicate the thing actually speeding up since they all started at 0, but these ones indicate that it speeds up moving towards the detector. So the slope of a velocity time graph tells acceleration. The steeper the graph, the faster the acceleration, the more its velocity changes every second. When we're looking at velocity time graphs, if something is still, then its velocity is 0. So the velocity stays right on the 0 line. You'll notice there is no acceleration because the slope of this line is 0. If something is moving at a constant speed, it still has a similar looking velocity graph, it's just it's not on 0. It's a horizontal line somewhere else. But again, it's a horizontal line. There's no acceleration because the object is not speeding up or slowing down. Okay? But when we do have things that are speeding up or slowing down, then we're going to have sloped velocity time graphs. And if we use that, we can calculate the slope to find the acceleration. So speeding up, moving away. If I'm going to say speeding up, I'm going to start slow. And the slowest I can go is stop. So I'm going to start at 0. Away means above. So speed up, move away. It just has to be a line that slopes up over here. This one's sped up from 0 meters per second to 4 meters per second. Speeding up, moving towards. Again, speed up means I'm going to start slow. I'm going to start at 0. Moving towards means it's got to go negative, and get faster means it's got to get away from 0. So here's a velocity time graph that shows speeding up, moving towards the reference point. Slowing down, moving away means it needs to be positive because it's a away motion. Slowing down means it needs to start quick and get slower. So this one actually slowed down from 4 meters per second to 0 meters per second over a course of 7 seconds. The slope of this line is negative 4 meters per second, right? The change in velocity divided by the run, 7 seconds, and that's going to get me negative 4/7 meters per second per second. And then finally, slowing down, moving towards. Moving towards means it has to be a negative velocity. And so I got to start here. Slowing down means it needs to get from fast to closer to 0. So there's a slowing down, moving towards velocity time graph.